Sometimes you need to integrate an improper fraction. In algebra, a proper fraction is one where the highest power of x in the numerator is lower than the highest power of x in the denominator. So for an improper fraction, the highest power of x in the numerator is either the same as or more than the highest power of x in the denominator. The first kind that arises is where you just have a single term in the denominator, and this often arises after you've made an algebraic substitution in your integration. So either you can divide each term of the numerator by the single term in the denominator. So in my example, the single term is x squared, and we can divide each term of the numerator by x squared, and then we get a sum of terms, each of which we can integrate. Alternatively, the x squared on the bottom line can be written as 1 over x squared, which is x to the power minus 2. Dividing by x squared is the same as multiplying by x to the power minus 2. Then you multiply each term in the brackets by x to the power minus 2, and then you get the sum of terms which you can integrate. The next type is where you have more than one term in the denominator, and the denominator can't be factorized. This time you cannot use the previous method. You can't write this as a sum of terms. So either you use a substitution and let u equal the denominator, or you rewrite the fraction as a number, or a polynomial, and a proper fraction. You can do this using whatever method you're used to using for algebraic division. For simple ones like this, one way is to think about it as 4x plus 3 could be written as 4 lots of x plus 1. I got the x plus 1 because that's what the denominator was. And then I need to make an adjustment. 4x plus 4 lots of x plus 1 would be 4x plus 4. And I want 4x plus 3. So I have to take away 1. Now I have 4 lots of x plus 1 over x plus 1, and that simplifies to just 4, minus 1 over x plus 1. And now I have an integral with two parts, each of which I can integrate. Instead of using this method of division, you could use algebraic division the way you did it in the first year, but x plus 1 doesn't divide exactly. You get a remainder of minus 1. We could have done the same one using a substitution. You let u equal whatever was in the denominator. So in this one, dx will equal du. X will equal u minus 1. And when you complete the substitution, you get 4u minus 1 over u, which can be written as 4u over u, because we now have one term in the denominator. So that can be written as 4 minus 1 over u. And it's the same integral as we had before. Remember to write your answer in terms of x. The final kind is where we have a product of factors in the denominator, and so you need to use partial fractions. I want to find this integral. I'm going to call it I, so I don't have to write it out again. It is not a proper fraction. The highest power of x in the top line is the same as in the bottom line. So I first have to write it as a number and a proper fraction. So I started by writing 9x minus 4, sorry, 9x squared minus 4, and then making an adjustment. So I wanted plus 2. So instead of minus 4, I've written minus 4 plus 6. And there was also the minus 3x. So I have 9x minus 4, 9x squared minus 4 over 9x squared minus 4, which gives me 1. And then I have minus 3x plus 6. It's usual to write this fraction as with numerator 6 minus 3x, so that it's obvious that the minus sign only applies to the 3x. I then need to express the proper fraction in partial fractions. You always have to write your fraction with, you always have to start with proper fraction before you can write something in partial fractions. And now my integral can be written as 1 plus, and then a sum of two partial fractions, each of which I can integrate.